Today my guest is Brian Prince of Microsoft. Brian, how you doing?
Good. How are you doing, Dave?
I'm doing well. Welcome back to the show.
Thank you.
And I just saw your presentation on Windows 7.
Yes, it was it was the under the hood of Windows 7.
Under the hood was
why it rocks.
I found it really interesting because I've been running Windows 7 for about 2 months now, and I like it a lot. Now I know a lot of people didn't like Vista. You liked Vista.
I liked Vista. It was a good, solid operating system. It did a lot of things. It fixed a lot of things. For the 5 years I ran it, it never crashed on me. I mean, never blue screened on me. You always have the evil video drivers here and there that break things, but in general, I had a great experience with Vista.
But you really like Windows 7.
I love Windows 7. I mean, it's like having that old reliable. Like I had a Saturn car right after college. Back to the metaphor thing. I loved that car.
I'm going to break the fourth wall here.
Yeah.
So every time Brian uses a metaphor, take a drink.
Yes.
That's the game we're going to play. Go ahead.
Yeah. I liked that car, that Saturn. It was easy to buy, easy to run. It was dishwasher safe. It was a great car. I'm still a fan of Saturn. But then I bought an Eclipse Spider convertible. I loved that car.
Once you go to Spider, you never go back.
Yeah, because it was fast and it was sleek and it was... and all that. And that's the same thing with Windows 7. It's just, to me, there's been three families of Windows, right? There was the Windows 3 generation, and then we had a clean break, almost a clean break. You still had backward compat support, but we moved into the Windows 95 generation.
Where DOS kind of went away.
Yeah, effectively, and 98 and Me and XP and all of that. And then we had another kind of major break or generational line with Vista, and so Vista took the brunt of that with OEMs being ready with drivers and applications being compatible with the new, more secure ways of doing things. Right, you could play fast and loose with the rules in XP. We didn't let you do that in Vista.
Okay.
So Win 7 is the next step from that, building on what Vista laid down. So it's gonna have an easier time because the maturity of the environment's already up to speed.
Yeah,
to a great degree.
And we don't have that shock value of among like the people writing drivers.
Yeah,
they're ready for it.
Yes.
Vista drivers all work with XP, right? Or with, with Windows 7.
Yeah, for the most part, all Vista drivers work with Windows 7. That was a goal of the team. Actually, was that if the app ran on Vista, it should run on Windows 7. If the hardware worked on Vista, it should run on Windows 7.
Okay, so it's more than that though. It's more reliable. It's faster. It's what else? More stable.
Yeah. So the stability, performance, and simplicity were some of the key themes that the team had as they were designing and building Windows. Yeah, I almost did it again. Windows 7.
Well, let's go under the hood. Why is it faster? Tell me a couple things.
Well, there's a lot of things they did. I mean, they went across the board through every module and squeezed it for memory and really shrunk those modules down, and they have smaller footprints. But some of the more concrete things, for example, boot speed is much faster because most services aren't loaded anymore. And if they are loaded, because they're required to be loaded at boot time, they load in parallel. So in Vista, you could have delayed start of a service where it would delay by 2 seconds.
Okay.
I'm sorry, 2 minutes.
Right.
It would start on a low priority thread, and so that service would let the machine boot up, get you going, doing what you want to do, and then it would load in the background.
Okay.
With Windows 7, you can still do all that, but now you can tie it to a trigger event of some sort. So the service will actually be dormant, disabled, until that trigger event happens, and then it will get loaded and executed. And so that not only makes your computer boot faster when so many of them are dormant, but because they're not running all the time, you reduce the memory footprint, the CPU footprint, and that extends the battery life of a laptop.
It extends the battery life. So if you never fire up anything that's going to use that service might never start at all.
Correct. Yeah.
All right.
And triggers can be the clock, a packet coming in on or unplugging the network, anything in the Windows event log, and this isn't just for our services. This is if you're writing a service, you can use those APIs to hook into events as well.
Yeah, I have that issue. I have a home computer that I have SQL Server on there because every once in a while I used to develop on, but I rarely actually use SQL Server.
Yeah.
SQL Server is a service. It starts up and it's not cheap.
Yeah.
It takes a while to start up. It takes a lot of resources. and it takes away from what I'm doing. So
Yeah.
I had switched it to manual startup,
Mhm.
which is inconvenient
Yeah.
when I want to use it. You're saying this takes care of that for me.
Well, if the SQL services were written based on these triggers, right? So
Oh, okay.
the service has to support that
It's
capability.
up to the writers of the service to
Yeah.
to implement that.
Yeah.
Okay. What else? Tell me some more features, some under the hood stuff that.
Briefly, because I have yet to find a good way to explain it as well as the guys on Channel 9 do that actually work on the kernel.
Yeah.
But user mode scheduling avoids all the context switches on the kernel threads. So basically what that means is we're lazy synchronizing with the kernel. So the more I can stay in user mode, the more performant my CPU is going to be.
Okay, and then we're talking about synchronizing the kernel. You're talking about synchronizing between threads, switching context?
Yeah, so like a user thread, there's also a kernel version of that thread. And so if I have 4 user threads, I'm going to have 4 kernel threads.
Okay.
And so I'm constantly going into the kernel and synchronizing to the right kernel thread and coming back out for nothing, pretty much for nothing. And now I don't have to do that. I can switch around, what running thread happens in user mode all I want. And then once I need to go into kernel mode, it will then synchronize to the proper kernel thread and then execute.
Okay. So that's some good points on performance. What about reliability? Why is it crashes in less than previous versions? Right?
Yeah.
That should be a good marketing slogan.
Yeah, I don't know. Yeah, it sucks less than. I used to do marketing for retail brands, and,
Okay.
and that was always the challenge. Is you can't put new formula on. It's hard to put new formula on a product
Because it implies the old formula.
because it implies the old formula sucked. I guess one thing that I was really excited about, I just think it's a great piece of magic, is the new fault-tolerant heap manager.
Okay.
And
And what is the heap for?
so the
those
heap,
of us
in
who-
general terms, heap is a block of memory an application is going to have access to.
Okay.
And there's a heap manager that doles out memory, right? And in unmanaged code, you're asking for memory and then freeing up memory all the time.
Unmanaged code meaning not .NET.
Not
code.
.NET, right?
C++ code.
yeah, and
COM code.
yeah, and learning about the fault-tolerant heap manager reminded me why I started using .NET and moved to managed code, because you don't have to worry about memory management quite nearly as much as you do in unmanaged.
Yeah, and I've always been a .NET developer, and before that a VB developer, which still
Still did a lot of
abstracted that
for
away
you.
from me.
Yeah.
So I never had to worry about that. So what does this memory manager or this heap manager do?
So there's a service running, the fault-tolerant heap service, and it looks for heap corruption related crashes in the event log. If it sees an app crashing a certain velocity, I think they're set to 4 times an hour, it will go on the FTH list. That means when that app starts up, it's effectively injected with the fault-tolerant heap manager. So the normal manager is always there. The normal heap manager is always there. A badly performing app will get the FTH injected in the middle of between the app and the real heap, and it'll intercept all of the calls to the heap.
And what does it do during that interception?
It does a lot of things. For example, there's 4 major things that it can do to help fix the heap problems from people not managing memory correctly. One is it can zero out the memory before it gives it to you. So if you're in your code, you should initialize your variables, but if you're not, and that somehow causes problems, they zero it out for you.
Okay.
Another thing is they can, if you allocate a buffer, and because you mess up pointer math or something like that, and you write too far out that buffer, just by a little bit, because you're the off by 1 problem,
Okay.
what they do is they give you ask for, let's say, 12 bytes. They give you back 12 bytes, but actually into the heap, they actually allocate 12 plus 8 bytes. They tack on an invisible buffer.
Ah.
So that when you write over by accident, it works and you don't crash. You don't write into someone else's space or
Okay,
or
so that's,
into one of
that's,
your
that's
other
the risk,
variables.
is you ask for 12 bytes and you accidentally, there's a bug in your code that writes to the 13th byte,
Yes.
even though you've only allocated 12.
Mhm.
And then someone else comes along and allocates that 13 bytes to some other
Right. Or
section
that's
and then they're expecting that to be something different than what it is.
right. Or that byte was a byte from one of your other variables.
Right, so you've overwritten data.
Yeah.
And then you wouldn't know about it until you go to read that data.
Right.
Which could be
and that could cause
much
a
later.
crash.
It's
Right.
tough to debug that.
Yeah. So a couple other things it does is there are problems with freeing memory in the right order. Another problem that I'm not very familiar with, but they call it a double free, where they're trying to free memory more than once. Trying to write to memory after it's been freed in a kind of a race condition scenario. And so one thing they can do is actually, when you say free this memory, they don't free it. It's almost like the memory manager in .NET, where they actually keep it around for a little bit. There's actually a queue. But it delays the freeing action by a few seconds, effectively, to keep that race condition from really spoiling any fun. And then it frees the memory later. So, and then the fourth one is just not freeing memory when it actually is asked to free the memory, like on shutdown. It'll wait till everything is completely shut down and then free all the memory, instead of doing it the way that the application wants it to do.
Oh, can the heap manager help that then?
Yeah, the FTH helps that. It kind of keeps all the references in play until the app is completely cleanly shut down, and then it will clean up all the memory.
Okay, a little bit like garbage collection and .NET.
Yeah, I think it's, in a simple way, that as I understand it, I think that's the way it
Okay.
works. Yeah. So, and this, only kicks in when an app is bad behaving.
Yep.
And we have a list that the service can call into on the internet that we provide of applications that it absolutely does help, and you should always do it for this app, for that version of the app, and it absolutely doesn't help, don't even try.
So there's a list somewhere out in the cloud
Yeah, that we manage.
that's managed by Microsoft. It's a database of applications and the issues that those applications have.
Yeah.
And how this FTHM can resolve them.
Yeah,
And when does that list get queried?
I think on a regular basis.
Okay.
I think maybe when it finds it, this is where I'm skiing over my tips a little, but I think when it actually finds a new app, it can pull it and ask.
Oh, okay.
And there's apparently some things you can do in the registry to monkey with this, because I was talking to some developers earlier today here at Sagetti, and they didn't. If I'm actively working on an app and trying to get it to crash to fix the bug, I don't want this thing keeping it from crashing on me.
Yeah, it's tough
so I
to
want to be able to
test
disable it. Yeah.
What's going on?
But at the end, the users are going to have a better experience, and that's what it's really about.
Yeah, absolutely.
So if you're watching this show, you're probably tech support for your family.
Guilty.
I'm just guessing.
Yeah.
And so the new Action Center, which is the flag down in the sys tray, the white flag,
Systray is a little part of the taskbar on the far right side.
down by the clock.
Yeah.
Yes. And that's the troubleshooting center. The problem with diagnostics for any application is there's a lot of work for the developers to do to perform the diagnostics and to fix it. They have to build UIs, monitoring. There's a lot of plumbing involved just to do that little bit of work to fix the problem. So what the team on Windows 7 did is built the diagnostics engine and all that plumbing for you, and then you provide effectively some PowerShell scripts in a signed cab, and that can find the symptoms and validate the issue, fix the problem, and then validate that it's actually been fixed. And you write all those scripts in PowerShell, so there's no UI, there's no weird APIs you need to learn. It's just everyone knows PowerShell, or can easily learn PowerShell.
Yeah, I've been reading PowerShell a lot more since it started getting installed with Windows 7.
Yeah.
So does Windows 7 ship with some of these scripts already? Some of these
there's
diagnostics and fixes.
Yeah, I don't know how many. There's a bunch in the box, and there's a local diagnostic store, if you will, and then there's a Microsoft library that it can pull and pull down new ones as we publish them. So as Windows 7 ages, we can continue to publish these, and ISVs, IT departments can write their own.
So if I've got a product and I want to help my users out without spending a lot of tech support, I can automate that by just plugging into this model, system tray model.
You can ship the cab to them, tell them to right click, it installs it all, and then runs it.
Or make it part of the install of the product.
Yeah, you could have your product do the syncing, all of that stuff, So that's a pretty powerful thing, and the goal also is to keep the UI simple, as few clicks as possible. We have to remember these aren't developers running these scripts. They don't even know scripts are happening. It just says Windows is now checking your display driver. And,
right.
And there are events that you can pass back, or messages that you can pass back up of your progress, and or if you need some user interaction, you can say, "Hey, ask them this,"
Open up some dialogue.
and the plugging makes the dialogue for you.
Oh, so I don't have to code a dialogue box.
Right, yeah, and
Beautiful.
interpret it. You just get that message back.
Okay.
Yeah.
Do you have a favorite feature of Windows 7?
Oh man, suspend.
Suspend?
Yeah, I mean, I never suspended an XP. It just wasn't worth the trouble. Vista was pretty good at it, usually. But Win 7 just nails it solid. I open my lid and I can log in, because mine has to be password from suspend. And I'm literally, the second I'm done opening the lid, I can start typing my password.
Oh, much faster back from the sleep mode. Or
Yeah. As I understand it, there was a suspend guy, or girl, I don't know, a person, who was the suspend person that was the point person. Whoever that is, can I break the fourth wall?
Go ahead, do it.
Whoever you are, I love you, because it just works. It works awesome.
Yeah, throw out
So-
a metaphor too. We haven't had one.
Yeah, I haven't had one in a while. My love for you is, yeah. My heart quickens like the suspend of my laptop.
Yeah. Time to crank.
That's not vodka.
What's I didn't say that. But awesome. Where can people find out more about Brian Prince?
www.brianhprince.com.
Okay, that's your blog.
That's my blog.
All right. Well, you know what? I've seen in the last 27 hours, I've seen you give 4 talks.
Yeah.
So I think you're pretty tired.
I'm a little tired.
I really appreciate it. Thanks
No
a
problem.
lot.
Thanks for having me over. In most of my friends, the one common theme has been our love for technology.